Good morning, students. We continue this session with second video. So in the second video we are going to see some important problems in the third lesson. So first example 3.10. Okay, now I read the question and listen carefully. A particle of mass 2 kg experiences two forces, F1 vector equal to 5i cap plus 8j cap plus 7k cap, and F2 vector equal to 3i cap minus 4j cap plus 3k cap. What is the acceleration of the particle? So this is the question, student. So what is the given here? The given mass value of a particle, for the same mass the two forces applied, the two force value also given here. Okay, so we have to calculate what is the acceleration, that is what is the total acceleration of this particle. Now we solve this problem. First write the given data. The F1 vector is equal to 5i cap plus 8j cap plus 7k cap, and F2 vector equal to 3i cap minus 4j cap plus 3k cap, and mass is m equal to 2 kg. So we have to find the acceleration. So this is all the given data. So now we solve this problem. Solution: to find the acceleration of the particle, we know only one formula for finding the acceleration, that is from Newton's second law, F is equal to ma, and we rearrange the formula. So we get A is equal to F total force divided by m. Students, here the F is split into two forces, so we have to add the two forces and we are going to combine, we get the total force. Therefore the total net force is equal to F vector plus F1 vector plus F2 vector, and substituting this value in the equation, so we get, so F total force is equal to F plus 3i cap plus 8 minus 4j cap plus 7 plus 3k cap. So this method we already studied in the second lesson. Only the component will be added separately, the I component in both force value and j component in the both force value and the k component in both force value, and finally we get the total force is equal to 8i cap plus 4j cap plus 10k cap. Now we find the total force value and substitute in the acceleration formula. Therefore A vector is equal to 8i cap plus 4j cap plus 10k cap divided by 2. Now this 2 is common for 8i cap, 4j cap and 10k cap. So I separate this 2 value for each term. So I get A vector is equal to 8 by 2 i cap plus 4 by 2 j cap plus 10 by 2 k cap. And dividing this, we get the final value, that is acceleration of this particle of 2 kg mass. A is equal to 4i cap plus 2j cap plus 5k cap. So this is a very important 2-mark problem. Students, next problem, example 3.13. Okay, so I read the question, listen carefully. The position of a particle is represented by y is equal to ut minus half gt square. We have to find what is the force acting of the particle, and also we have to find what is the momentum of the particle. So these two things we have to find. First I explain this question. Now the object is moving, okay, in y direction, because they are represented in y equal to. So the object is moving in y direction. Therefore the position of the object is represented as ut minus half gt square. Okay, the displacement time relation equation. Okay, now using this equation we have to find the force value. Also we have to find the momentum of the particle. Momentum means what is the changing value. Okay, so we solve this problem, student, and listen carefully. Students, first you write the given data. So the position vector y is equal to ut minus half gt square. Okay, first we are going to calculate the force. So how to calculate the force and momentum? Only we know the acceleration value of the particle. Okay, so but they are not given the acceleration of the value, particle value, but instead of this they are giving the position vector, that is displacement value they given. Okay, so since we know the acceleration formula, a is equal to dv divided by dt, so acceleration represented in the first derivative form. But here they give the y value, so we can substitute, since we know v is equal to dy divided by dt, and we substitute there and we get what? A is equal to d square y divided by dt square, that is the acceleration represented in the second derivative form. So first thing, we have to find the force and momentum. So for calculating the momentum, we need mass into velocity, isn't it? So first I am going to calculate the velocity. Okay, since the velocity v is equal to dx by dt, and rearranging this formula, here the object will moving in the y component, y direction, so we rearranging the formula as what? V is equal to dy divided by dt, and substitute the y value here. What is y value? Ut minus of gt square. So therefore v is equal to d by dt into ut minus of gt square. Now we are going to differentiate this equation with respect to time. So we just split this equation also, so we can write dut divided by dt minus du d by dt into of gt square. Okay, then we just differentiate this equation with respect to time, so time getting cancelled, only we get the u value, and also here we get the g into t value, because the t square one term will be neglected, so we get velocity v is equal to u minus gt. Now we are going to calculate the momentum. Since the momentum formula we know mass into velocity, so substitute the v value and we get, so momentum of the particle, so m u minus gt. So this is the momentum of the particle in y direction. So next we calculate the force value. Since we know the acceleration a equal to dy divided by dt, and substitute here the v value, so we get a equal to d by dt into u minus gt, and differentiate with respect to time, so the u term will be neglected and we get a is equal to minus g. Therefore if the particle is moving in the y direction, the force will be equal to F equal to minus mg, that is the acceleration is converted into acceleration due to gravity. Okay, so this negative sign implies that the force will be acting in the opposite side of the y direction. Okay, so this is very important conclusion, students. So the minus sign represents the force applied in the opposite side. Students, next example problem 3.16. Okay, an object of mass 10 kg moving with an speed of 15 meter per second hit the wall and come to rest within 0.03 second, and the second time 10 second. So the two timing will be given for the masses. Okay, so for mass 10 kg the speed of the object will be moving in 15 meter per second. So they given the two different timings of the same masses. So we are going to calculate the impulse. Also we are going to find the what is the average force of the object in this two different timing cases. Now we solve this problem. Students, first we write the given data. So the given mass value m equal to 10 kilogram and velocity v equal to 15 meter per second. So we have to find the impulse and the average force. So first thing, to calculate the impulse we have to know the momentum. Okay, so first of all I am going to calculate the momentum. So to calculate the momentum we need the change in momentum, that is del p, from the initial momentum to the final momentum value. So we solve this problem, then you may understand. Okay, so solution for calculating the initial momentum, so we know mass into velocity is the initial momentum, therefore pi equal to 10 into 15, we get 150 kilogram meter per second. Then we are going to calculate the final momentum. So final momentum pf equal to 0, kilogram meter per second, because now the object at the rest, so the velocity will be equal to 0, then the momentum will be also 0. Okay, next we are going to start our impulse. Okay, to calculate the impulse, we already know the impulse and the momentum are equal to same, isn't it? So therefore impulse J is equal to del P, and we know the del P value, the final momentum minus initial momentum, so the final value will be equal to 150, and substitute here and we get the J is equal to 150 Newton second, that is the unit of impulse is Newton second. For the second value also we get the same value. Okay, then we are going to calculate the average force. So for average force we are going to take the first time T is equal to 0.03 second. Okay, therefore the F average is equal to del P divided by del T, and substitute here. So since we know del P equal to 150 divided by 0.03, okay, after we get this value, the force average at timing 0.03 second is what? 5000 Newton, that is the force equal to 5000 Newton. And calculating the average force in the after 10 second, so we have same formula. So F average is equal to del P divided by del T, and substitute del P equal to 150 divided by 10 and cancel zeros and we get 15 Newton. Now see the conclusion between impulse and the average force. Here for the same particle, okay, we having the impulse value will be same, but the average force will be different from one another. Okay, so that is the very important thing. Students, next example problem 3.17. See the question. Consider an object of mass 2 kg resting on the floor. The coefficient of static friction between the object and the floor is mu s equal to 0.8. What is the force must be applied on the object to move it? Students, first I explain this question. A 2 kg of mass is at rest in the floor. Okay, so the given the static friction value, coefficient of static friction value, that is mu of s is equal to 0.8. So we have to find the force. Okay, so first thing, what is static friction? When the object is at rest, initially the force is applied to move the object, then the static friction will be opposing the applied force, isn't it? So that we are going to find here. Now we solve this problem. Write the given data. So the mass m equal to 2 kg, coefficient of static friction mu of s equal to 0.8, and we have to find the applied force. Okay, so we solve solution from the free body diagram. When an object is at rest, using the free body diagram, we know two forces are acting. One is normal force upward direction and downward gravitational force. So the normal force is represented as N and downward gravitational force is represented as mg. So I am going to equate N is equal to mg. Since we know G is equal to 9.8 meter per second square, and substitute here, therefore N is equal to 2 into 9.8. So just to keep this value, why? Because for calculating the static friction, we know mu of s, that is F of s equal to mu of s into N, isn't it? So now we find the N value and we know the mu of s value, and we multiply these two things and we get the answer. So substitute this value in the formula, we get the maximum static friction F of s maximum equal to mu of s into N. So and substitute we get 0.8 into 2 into 9.8 and multiple all the value in the right hand side, we get 15.68 Newton. Okay, now listen carefully. The static friction and the force will be equal, because the initially what is the force is applied on an object will be equal to the static friction, isn't it? So therefore the static friction value will be equal to applied force, that is the external force. Therefore the force of the object to move the 2 kg of mass at rest is what? 15.68 Newton. Okay, so up to this we are going to stop this today's session, students, and